Okay, so let's go ahead and talk about factoring on a higher level here. Here's our first problem. Negative x squared plus 13x minus 36. This doesn't seem too difficult, but you always have to watch out for a negative leading coefficient. Anytime there's a negative 1 leading something, you have to take that out. So what we did is we factored out a negative 1, and you guys know when you factor out a negative 1, the signs just change. Now let's examine what the trinomial is. So I'm going to organize my work. I need numbers that combine to a negative 13 but multiplied to a positive 36. Let me list all of those numbers out. I know that the signs are going to be the same because 36 is positive. Down there, my last set that I wrote, the 4 and the 9, that's going to be the magic set that I need, but they both need to be negative. So this original trinomial is going to factor to this form right here. Remember, the point of this, if there is a leading negative, you must factor that out. Let's go ahead and take a look at this term, or this expression. If you notice x isn't squared, the leading coefficient is the leading term has an exponent of 4, which is totally fine as long as the middle term is half of that, which it is. It's x squared. X squared is half of x to the 4th. So y'all, we can just factor this like normal. So I can just pretend that's like x squared minus 10x plus 9. Let me organize my work here. There's those factors that we need. So what I'm going to do is I'm going to draw 2 sets of parentheses, and that x to the 4th, I'm going to distribute evenly in the 2 sets, which means x squared has to go in the first one and x squared has to go in the second one. And then I'm going to go ahead and write my sideways numbers. So factoring like a boss means you're always checking to see if you can keep going. You can certainly keep going here. Both of these are differences of squares. That's plus 3 and minus 3. This is plus 1 and minus 1. So this is going to turn into all of these factors pushed together. Now look, if you notice, my bottom factored form has 4 x's. That's going to match the x to the 4th, the 4th degree. 4 x's are 4 degrees. I am good. I can box this in. Let's take a look at this one. Remember, 4 terms, you just turn it into a GCF problem. Break it into 2 separate groups and then factor out what you can for both of them. So for this next term, this next set, I factored out an 8. That's not a big deal. You guys should already know that. However, I am pointing to a sum of cubes. You got to make sure you're on alert for stuff like this now. So I'm going to go ahead and factor that sum of cubes. I'm going to hang on to that factor and just put it at the end. So remember, you root it. You square the first term, you square the last term, and you just multiply the 2 pieces together. But don't forget to bring down the x minus 4 because that's the factor for the original problem. There you go. That is in factored form. The very last one we're going to look at is going to be 12ax to the 3rd minus 20xa squared x squared minus 3bx plus 5ab. Okay, what I was doing, and I was just making sure I couldn't factor anything out. There was a lot of stuff going on there, and I cannot factor anything out. So here we go with just a GCF problem. Remember, when you're looking at stuff like this, just slow down. And remember, when you're factoring a GCF, it's just dividing what they have in common. I know they both have an a, but you got to take the lowest exponent. So I'm taking a single a out. 12 and 20, they're both even. I could take a 2 out, but that won't work. You got to take the highest out. The highest out is going to be a 4 for 12 and 20. Always look for the highest value that you can factor out. All right, and one more thing that I didn't mention. Remember, they both have x's. The lowest exponent is x squared. So here we go. I'm taking a 4ax squared out of my first set. So now I'm just going to divide through here. Go ahead and get my stuff going. Just dividing, making sure I did it right. For this next set, guys, we have a b, but I have to factor out a negative b because the signs have to match. So this is going to turn into 3x minus 5a, which is perfect. Now my terms match. So of course my first factor is 4ax squared minus b. The last term is 3x minus 5a. And that's going to be it. I'm just kind of checking to make sure I cannot keep going. I can't. So I'm good. I'm comfortable. I'm going to box that in. Okay, so here's just a little Easter egg for you, a little surprise. How to determine whether something is factorable or not. So maybe you're taking a test or a quiz and you're like, I cannot find any factors that are going to make this. I'm going to show you a way where you can comfortably write prime and go ahead and move on without worrying that you missed something and overlooked something. So what I'm going to do is I'm just going to go ahead and try to factor this. It's not going to be factorable. I'm listing all of my numbers. A negative 10 and a negative 1 would make that, but remember that 10 is negative, so I would have to use opposite signs, which would be impossible. So I know this is prime, but let me just prove it to you. I'm going to show you using the quadratic formula. Remember, the quadratic formula is negative b plus or minus the root of b squared minus 4ac all over 2a. All I care about is just that piece right there. I'm going to use that to prove to you that this is prime. So I'm going to prove to you that it's prime because we are not going to get a perfect square here. Watch what I do. So remember the b value, y'all, is negative 11. Negative 11 squared is a positive 121. And then minus 4 times the a value, the leading coefficient is just 1, times the c value, which is your constant, so it's a negative 10. This is going to turn into 121 plus 40, which is 161, and that is not a perfect square, which means that trinomial is indeed prime. Now, let's say that it was x squared minus 11x plus 10. I'm going to prove to you now that it is factorable. So remember, a negative 11 times the negative 11 is a positive 121 minus 4. So now I'm going to drop in the a value, which is just a 1. I'm going to drop in the c value, and that's a positive 10. So this is going to be 121 minus 40. And 121 minus 40 is 81. 81 is a perfect square. So if 81 is a perfect square, this trinomial is factorable. And of course it is. You guys should have already recognized it's x minus 1 and x minus 10. There we go. I do want to mention though, like even though it is a perfect square, you know it's 81, and the square root of 81 is 9. 9 has nothing to do with the factoring that we're doing here. We're just focusing on it being a perfect square. So for this one, let me prove to you that this is going to be factorable. I'm going to take that b value, I'm going to square it, minus 4 times a times c. So it's going to be 25 plus, let me go ahead and grab my calculator real quick because I don't know what 4 times 36 is in my head, plus 144. All right. So when we do 25 plus 144, we get 169. 169 is a perfect square. 13 times 13 is 169. Which means this trinomial is factorable. And of course it is. This trinomial factors to these two factors right here. Let's go ahead and take a look at this one. So I'm just doing b squared minus 4ac. This time it's going to be 36 minus 144. I get to stop right there because if I did 36 minus 144, that's a negative number. There's no way that could be a perfect square. So this is absolutely prime. The last one we're going to look at is going to be this trinomial here. So again, I'm taking 14 and I'm squaring it. 14 times 14 is 196 minus 4 times a times c. And this is 196 minus 24, which is going to be 72. Not a perfect square. I am writing prime and moving on. Oh, and I lied. This is going to be the last one. Now listen, before I can determine if it's prime, you have to make sure you factor out any GCF. All of those numbers were even, so I know I could factor out a 2. Now I can check to see if this is prime or not. So it's going to be 4 minus 4 times A times C. So this is going to be 4 plus 40, which is 44, and that's not a perfect square. So this simply just factors to this expression right here.